Hello again, everybody, and welcome to our final session of the 2024 Robotics Application Conference presented by Corber. This is Tim Culverhouse once again, Editorial Director of Robotics 24/7, and I'll serve as your moderator today for our Pick-in-Place session that's going on. And the title of this presentation is Pick-in-Place Automation. So many options, how to choose. Now, for our audience, before we start our presentation and discussion, let's go over some housekeeping. If the slides accompanying today's discussion aren't advancing in your window, please hit the F5 key to refresh your browser. Viewers who would like to download a PDF of today's slides and other supporting documents can do so by clicking on the blue paperclip resources box that you can find at the bottom of your browser. You can also access these resources on the Pick and Place session page at Robotics 24/7. Now, if you're experiencing other technical difficulties with today's program, please click the orange question mark box at the bottom of your console for further help and instructions. Manufacturers have many options to automate picking lines than ever before. AI, sensors, and robotic gripper technologies are developing fast, and the number of suppliers is growing rapidly. It's so hard to keep up. Now, among these options, how do you choose the solution and supplier best supplied for your needs? Now, to speak about this topic and highlight the role in pick-and-place applications across industries, I'd like to introduce our guest for today's program. Mikkel Vieja is the robotic engineer, co-founder, and principal advisor at How To Robot. And Mikkel, thank you so much for joining me as part of RAC 24 and leading this discussion in our Pick and Place session. Mikkel, over to you.
Likewise, very, very nice to be here and happy for you to have me. All right, I will just dive into it, and hopefully this should enlighten on a few new ideas and how to proceed with Pick and Place. So yeah, let's get into it. We from How to Robot. So just for you to understand who I am and what background I come into this with very briefly. I'm from How to Robot. How to Robot, we help companies that want to automate. So we have very experienced in actually understanding the requirements and the needs of automating for a specific production or environment. And we try to translate that and match it up to suppliers in the market. So you could say we are unbiased matchmakers, taking a concept and an idea of what you need automation for, translating that into a solution that can actually run in the real world. We're based out of both the US. We have offices. Today I'm calling in from our Danish office, but we are a global company, so we have a bit of everything. All right. That cleared away. Want to move on to the hot topic of today, which is Pick and Place. So I thought I wanted to start with touching upon some of the technological tendencies that we see in the market right now in the work that we do advising companies out there. So just to put the scene right here. So when I talk about automation, I talk about physical robots as pictured here in the bottom picture, like robot arms or physical automation that can manipulate and actually do something to different objects or different processes in the real world. There's also some talk about RPA, which is more digital. That's not what we'll touch upon here. And then there's the whole topic on AI, which is a broad term. And one of the tendencies that we see right now is that this AI wave is actually helping a bit on the physical robot capabilities, just like it is in the RPA world and more in the digital world, basically. So what we see in terms of Pick and Place specifically is that for normal Pick and Place operations, you would need to program your robot very specifically to handle a certain object and a certain environment, basically. But with AI, we have the opportunity of actually training the physical translation, the physical operation of these robots. They can actually operate in an environment that is less controlled and which much more different activities happening, basically. So what we see is this wave makes it more possible for robots to work in a world designed for humans. We see that robots, especially for Pick and Place, can actually be trained rather than programmed. So instead of programming an operation, you can actually train the robot to do it without any programming skills by just showing it how it's done. And finally, we have the ability for a robot to actually adapt to real life situations. So if something it should pick is misaligned or slightly misplaced, it can actually pick it up still and continue as understand. So we see in general that right now the pick and place operations with robots and automation solutions is becoming much more robust and flexible and versatile, basically, which is a huge game changer in this environment. All right, that was the scene. So examples of where we see in our daily work that adoption of the plug-and-place automation solution is significant or less significant. And these are, of course, just examples. There's much more out there, but hopefully this will give an insight into what is feasible and what is less feasible or more complex, at least at this point. So we see high adoption of automation in some cases where you, for example, have end-of-line picking. That could be secondary packaging, as an A picture here, where you pack products that has already been wrapped into boxes. It can also be primary packaging, as in B, where you have the specific object that you want to put directly into a container or wrapping of sorts. We see a lot of backlit part picking, like in C, where you have light to help the computer vision detect the objects that you're picking. We see a lot in palletizing and depalletization, because it's structured and it's processes that actually is controllable. And then finally, we see a lot in machine tending, where you pick and place objects into and out of these machines to actually reduce the manpower needed to keep the OEE high on those equipment pieces. So that's some examples of the high adoption areas. Medium adoption, that would be, for example, in bin picking, because it's a bit more complex. You'd want the robot to pick inside a messy bin of different objects that are not easily aligned. That's more difficult. We see in food packaging and handling, you want to do a lot of picking of finished products that can actually end up in your packaging afterwards. But that requires that your pick is very delicate and that you don't hurt or harm the product in any way, so it leaves visible marks or defects. And then there is, of course, the heavy product handlings. That could be car manufacturing or in forging different metal pieces, where you'd have to handle something very heavy that requires more expensive solutions. So that's also medium adoption for now. And then final low adoption would be high mix, low volume. I'll come into that later. And finally, dynamic environments that is very interchangeable. So that's just to give an insight, basically. So the key barriers when we come out there. So when you have to decide which process to automate in your production line, in your setup, there are some things to look for and some things not to look for. And here we just start by the barriers that would normally limit a process from being automated. Then the next slide will be more in terms of the good things to look for. So indications here is if you have high variation in the pick parts, that could be that each part is unique or very few of the same size and shape that has to be pre-programmed. That's an indication that it will be more difficult because you need to find a universal gripper to put on the robots. That can be quite difficult. There can be something about the part design. So if it's an intricate part design that's complex, it can be more difficult to get a gripping device aligned with the robot, so it's more difficult to grip, basically. So that will also make it more complex to achieve something here. Deformable parts is an issue, because if a part is deformable or squishy, or maybe it can go back to its normal shape, but still you can leave marks and it's difficult to handle. So that will be an added complexity again in terms of the system. There can be the issue of an unknown process. So if you're unclear of the exact requirements to the solution that you actually want to implement, that is a very key step to get solved. Because if you cannot explain to a potential integrator of an automation solution what they should solve for and what the requirements are for the solution, it will be a mess trying to implement it. This is also some of the work that we do on a daily basis, is to help our customers clarify this and make it understandable so they know exactly what to ask for from an integrator. Finally, the last one is we see as a barrier is unrealistic payback expectations. So we've seen a shift in the market where, because of this cobot wave and all of this interest, there is sometimes an unrealistic expectation as to what should a payback period be. Anything above 3 years is normal. It's only rare cases that we see 2 to 3 years of return on investment on purchases of pick-and-place robots. They do happen, but we often see that depending on the scope of view, or who's making the calculation, it can be set artificially low or artificially high in that regards. So we normally always work on a total cost of ownership calculation that doesn't only take into account the robot itself, but also the whole thing around it, everything that needs to be changed, the running costs, the changeover costs, the training costs, and all of that, so you get the full picture when doing the calculation there. All right, so that was the bad part. Now for the good part. So what should you look for in terms of indicators of processes that could be nice to automate with pick and place? So the first thing would actually be low product mix. So you wouldn't have that many product variants, which would indicate that you could more easily teach a robot or an automation solution to pick some or all of them. But I've also written in here, it's also right if you have a huge variation of products, if you can just select a few high runners that would have enough numbers to fully task a robot solution or automation solution, that's also all right. So it doesn't have to cover your entire product range. It's a matter of getting enough numbers, enough quantities on a few specific high runners or high numbers that you can actually automate. That's a very good start indication. Then, if the current process of pick and place inside your production is the bottleneck for the entire production, that's also a good indication that there would actually be a business case, because then it's not only a matter of maybe retasking the operators that was previously doing the pick and place to another task and getting the effort there instead, where they provide more value maybe, but there's also an element of increasing the entire throughput of the production line just by improving one process. So that's one of the key areas we try to look first to see, all right, can we optimize the process itself, but also will the optimization of the process have a higher and better impact on the entire production line? That has to be taken into account as well. If you got a fast cycle time, so that would be a very speedy operation where you get a lot of products coming through, where an operator would effectively be locked to a station, so they cannot move elsewhere because they don't have the time between pick and place operations to go somewhere else, do something meaningful, and come back. Locking that operator there usually means that there is enough work for a automated solution to take over and have a good business case. So that's a very good indicator. It can also be a potential to implement automation for pick and place where you have a slow cycle time. That's the other way around. Say if it takes so long time between each product coming through, the time between each product, that the operator is not able to spend his time efficiently in other areas. So say you have an area of the production where the operator needs to be whenever something comes out every few minutes, but even if it's a slow cycle time, he don't have enough time to move over to another process and add something valuable there. So basically, he's effective a very small amount of his time, but he's locked to being in that cell to do that pick and place operation. That's also a very good indication of a high potential, although the robot will move slowly when you get it in and it's running. Quality issues, if you got quality issues such as misalignment in packaging, damaged objects, contaminated objects, or missing products in the boxes or the products that get shipped out. I mean, any quality issues can normally be significantly improved with automation. So the quality improves, but I would say more maybe the quality is more consistent. So if it's a robot handling the pick and place, there's less risk of an operator dropping, damaging, banging, or bending some of these products as they are handled. So that's also a good indication if you need something in improvements in that area. We recommend when we look at our production to be automated that you try to select a product or product range or product family that's the core of what should be handled, that will be in production for at least 2 years. Because normally that's the amount of time that it would take to get close to a break even in terms of the investment, say 2 to 3 years before. So anything from 2 to 3 years is normally where it ends up, but at least for 2 years, because sometimes it can be difficult and expensive to switch over a solution to work on a different product. So if you got a product you only know will run for the next few months, it's a different purchase of the solution because you need to make sure that it is adaptable to other elements in the future if you got a new product coming in. So if you got one product running for the next 2 years on a fixed contract, for example, that's a very good indication that it could be viable to invest in an automation solution. Final point on this, manual pick and place processes that cannot be made obsolete by production flow optimization. So here it's a matter of looking at this from the unbiased automation advisor side. We will never advocate for putting in a robot or automation piece just to put it in there. So we'd always recommend to go into the process, understand the specific process of what the operators are currently handling manual. But before you look into automating that, look further down the line prior to that process, earlier in the production, and see, is there anything that can be done there that would potentially make the whole or part of that pick and place operation obsolete? So don't automate it just to automate it. I mean, look further and see if you can change the process in any way to see if you can avoid that pick and place operation. It could be as simple as aligning a set of conveyors or a simple transfer chute or something that is less complex. So just to say, only add in automation and that complexity if it's necessary, but when it is necessary, it makes a lot of sense normally. All right. I brought a few cases just to get into some examples and details. Also, if you stick with this and let me get to the end, then there will be a reward of a lot of short videos where I also showcase some examples of what actually moving out there. So, case number one. Of course, with customer confidentiality and everything, I cannot say any names or brands, but I can definitely tell you about the case. So brought today is a case of palletizing. So we see a lot of pick and place and palletizing, and this project was for a company that had a central warehousing operation. And in that central warehousing operation, they had to do fulfillment for a lot of different shops around the world and around the countries. And the object here is that you get a whole pallet of one type of product in, and once you get that one type of product in, you need to break it down and you need to distribute it to different recipients. And that issue of producing mixed pallets with different products, different SKUs, different shapes and sizes on there can be very complex. So this is a pick and place task of heavy pieces, heavy products that are to be taken out of a storage area, put onto a pallet, and the pallet had to be palletized in a way where it would maintain balance, where the lower items would not get crushed by the one standing on top of them. And you need to make sure that this whole stacking is done intelligently, like we would be able to do as people. The robot needed to have the same expertise. So this was challenging because there's a high variation in all of these. And there's a huge number of combinations of which product needs to go on each pallet to get out there. It's not possible to train all of this in advance. It's basically something that has to be modular as a skill the setup can do, depending on what needs to be put on each pallet. It needed to be able to adapt with its own intelligence. It must be able to handle any tolerances in the products coming in. So this product packaging that would come in is never perfect, so it has to account for any differences. So it couldn't, for example, just place straight down a pack, because that pack would maybe be deformed in any way, so it would basically hit any of the other packages in there. So it has to kind of, just smooth its way in and make sure that it gets everything aligned on the pallet. And it needed to be highly efficient. So that's just an example of a palletizing operation that is a bit out of the ordinary. The simple ones is a bit more standardized. All right, second case. For machine tending, that is very widely used. You could say that this process is partly machining, but I'd say it's a pick and place operation, because basically, as you see in the picture here, it's a matter of feeding these rough metal pieces into a piece of processing equipment, and then once the piece has been processed, taking it out again, and putting in on another table or another container, basically. So this is often for metalworking, CNCs, lathes, bending processes, stuff like that. Normally, we say this is automatable if you got batch sizes of roughly more than 20 pieces. And hopefully, if you got different variants, they should be approximately the same size. As you can see on the left picture, on the left to the picture here, it is often based on a grid pattern with the modular trays, where the raw material would be standing, and it would kind of using gravity to drop down, so it's aligned all the time, so the robot can pick it up in the right place and doesn't have to re-grip it to get it aligned. This normally, in these cases, we've implemented it, frees up a lot of operator time. This is a good example of a case with a slow cycle time. So that would mean that it takes maybe 5, 10, 15, 20 minutes between each object has to come in and out. But because of that, it still ties an operator to stay in that vicinity to keep a high uptime on the piece of equipment that's machining. And in addition to saving the operator time, we see that a lot of our customers utilize this to actually extend the shift. So if they work an 8-hour shift and the machine is running 8 hours, they could actually load up the tray, fill it up, press start, and then leave for the day. And then when they come in the next morning, that whole batch will be done, basically. So it's not a whole additional shift, but you could actually get several hours of machining time without having anybody there, because it would just run that batch finished. Third and final case from my side, we did a case of packing frozen fish. And this is an example of products that are delicate and difficult to handle and not very rigid, basically. The project that we did was actually for breaded fish. So it was handling the fish, doing fish fillet, the breading, and then handling it after it has been frozen. And the issue here was they needed to place two pieces of fish inside each box that would then be closed, and that would go to the supermarket, basically, so you could buy it. And they were staffing that with some workers that were not very happy with the task they were giving. They would prefer to do other jobs because they were standing all day, basically just putting pieces into these trays. The difficulty here was that we needed to handle these pieces very carefully, not to damage the product, because if there was a suction cup mark on every single fish, the consumer would likely complain and be thoughtful of what the product was, if it was all right or if it was intentional that it was left there. We also needed to make sure that we could do some fast picking. So that meant that we, in this case, went for Delta robots, which can do very fast picking. And since the objects were not more than, I think it was like 100 grams each, that was actually doable. So it would pick up two, place them inside the box, and it could move on in the operation. It was very, very successful. When we do these types of solutions for food grade manufacturing, it has to be very cleanable. It has to be everything has to be stainless steel. You have to be able to clean every bit and piece. So everything becomes a lot more expensive, sometimes by a factor 2 or 3, depending on the situation. But it's often viable still. And finally, a key element that we have to remember in every single case where we apply automation instead of humans for pick and place is that when we're replacing the human, we also remove a pair of eyes, which would have done a maybe intentional or maybe an unintentional quality inspection of that product as they're handling it. So when you got a robot handling the product, suddenly there are no eyes, so you may need to implement a computer vision-based solution to verify that everything is as it should be to make sure the quality is maintained. All right. Moving on from the cases, just a few good advice on how to get started if you want to start with automation and what to go with in terms of finding the right supplier out there for you. Good advice from our side would be where to start. Maybe starting with the not good places to start. The bad projects we've seen has often started with an intent to join Industry 4.0, join digitalization, get on big data, or get on the wave of AI, because that in itself is not a good enough reason. It could be because you've seen the technology on a trade show. That's not a bad thing, but it shouldn't be the only reason to automate just because it's nice and shiny. Sometimes it's the management vision, so it's part of the strategy, but it should be founded deeper down to really make sense. And also sometimes vendors just suggested it and said the business case was good. There we'd recommend to go back and test and calculate your own business case just to make sure it's actually viable and beneficial. So what does a good place to start look like? Well, if you can improve productivity in the production line, if you can increase the capacity, if you can improve the quality and uniformity, safety and work environment. Sometimes it's also worth automating just to gain experience with automation and get knowledge so you can actually get to the next level in a future setup. Could be to gain a competitive advantage in the market. Sometimes to secure staffing. If staffing is difficult in your area, you can utilize the current resources better with automation. And finally, avoid outsourcing, basically, so you can keep jobs in the local areas instead of sending it abroad. All right. Approaching the end and the videos here. So when you choose a supplier and choose technology, then you need to consider two things. First, is the technology mature? Because you want to select whether your solution should be based on tried and robust technology or new and innovative technology. Both things will work. The example here is, do you go with a solution based on industrial robots, the traditional ones that needs to be fenced in for safety, or would you go with, for example, a cobot that doesn't need to be fenced in, but maybe will work a bit slower and maybe a bit less precise in some cases. So that's difficult to decide where you want to start, and that's also why we help the customers understand. If you get a quote for a solution from a vendor, how do you get a sense and a feel for, do you believe in the technology they've chosen for that process, basically? And there's a pros and cons of each. And for pick and place, if it has to be fast, we normally see the standard robots. If it has to be flexible, oftentimes a cobot could be useful, or if there's a time constraint, basically, in this. The same goes with AGVs and AMRs, less complex or more complex. So I think the key importance I want to stress when diving into a pick and place project is that when you select your supplier, you should try to find the right supplier with the right experience so you don't pay for reinventing the wheel. We've seen this many, many times, that if you need a solution to pick whatever you do in your production, try to find someone that has a proven track record of having done that before, because that will significantly reduce your risk. So all the projects we work with in three categories: the A1s, the A2s, and the A3s. The A1 solutions are for us off the shelf. We know we can point at multiple suppliers in the market that can just pull it off the shelf, put it on your shop floor, and install it with small adjustments. I mean, that's the safe bet because we know it's working and it's been tried and tested before. The A2s are the ones that we do most of because that's where it's difficult to find, because in the A2 projects, we are able to point at a lot of the technologies existing in other solutions and with vendors, but we are not able to identify and point our customer towards a specific integrator who has that specific solution put to use and has his specific use case, basically. So it could be a similar picking solution for a similar product, but it's not exactly that, and it could be a vision solution that would identify where to pick, but in a different setup. So we need to find somebody who is willing to take the risk of gluing these two together, but there's no real groundbreaking research in this. So A2 projects is often what we do the most because they often make sense with a little bit of risk. And then there's the A3 projects. The A3 is rocket to the moon projects. I like to call them research and development. Can be perfectly fine if you want to do those, but you need to do it knowing upfront what you're getting into and making sure that you actually have the intention and you know the outcome will likely be in 2 to 3 years. You might have a demonstration, a prototype, a video of something working, but it will not be running on the shop floor in the next 5 to 10 years, maybe because it has to be matured and tested and all of that. So if it has a strategic advantage, that could make sense as well. All right. Final information slide from my side. Then we move on to some videos and then back to some questions and details with you, Tim. So this summary is basic. I won't talk through all of it. You will also get the slides, so you can just download if you want to read on later. But these are the 8 key elements to a successful automation project in our opinion. So to succeed with automation, you should at least consider all of these steps along the way to make it right. I'll just flick through the 8 of them, and you can read more details on this, or feel free to reach out afterwards if you have any further questions or details to answer. So the screening up front is important because you have to screen for where does it actually make sense to automate. So instead of just diving in at a place where the operator seems busy, get a whole overview of all the areas you can automate, and then once the overview is done, prioritize and select the best place to automate, basically. Only once you've done that, then you're ready to dive into the next step, which is the technical feasibility. So that specific case chosen, we dive into the feasibility and evaluate, is it technically feasible? Is it financially feasible? And is the solution ready on the market? Can we find suppliers for that? That done, we know what should be automated. We can jump into the business case and actually write up and calculate what are the actual potential savings of this. Once you have that, it's possible to go into the market with an RFI, get budgetary quotes back, and just get an indication. There's no reason to get suppliers to draft up full-length firm proposal first. Get budgetary quotes in, get those evaluated, and get that result of all the previous work ready for CapEx approval. That would be all the information you need to make an informed decision of investing or not investing. Then you can do an RFQ process to get out and get a firm quote of that supplier that you like best from the first round. You can get a firm contract, you can start implementation, making sure they deliver as promised, and then optimize afterwards. So that's basically all of the steps through. But to keep this concise, I think I want to stop it at that, and then feel free to reach out if there's any clarifying questions afterwards. All right, for the final piece here, I may need a sip of water to get ready for this. So for inspiration purposes, a Pecha-Kucha concept is basically 20 slides of 20 seconds each. And instead of doing long videos or a lot of examples in here, this is the way I'll do it. So I'll just quickly talk through 20 examples of pick and place operations that we're seeing out there that could be either relevant or interesting, and a few funny ones as well, just for the fun of it. So when I click next, it will just play as a video. You should see it come up on your screens. All right, here we go. So the first one is computer vision based picking. As you can see, the metal pieces are identified from a backlit surface and then picked by the Delta robot to be sorted. That's seen in many areas, can be nice for many small pieces that needs to be picked up quickly and aligned for packing or for another operation. Another fast one is this. It doesn't have to be a robot. Every picking automation piece is interesting here. So this one has a capacity of 30,000 pieces per hour that's picking from a in-feed table down to a moving conveyor. Yeah, really, really fast. So if you want to go fast, maybe it's not a robot. On the more alternative side, for different cooking jobs, we see robots get introduced. Right now, it's more of a gimmick than actually a production improvement. But at least it's for a nice story for this one for picking salad. We see a lot of movement in agriculture. We see a lot of different solutions out there trying to get into the fruit picking market. This one is an apple picking robot. As you can see in the speed, it's not necessarily very fast, but it can move along unmonitored and actually pick at a nice rate all day. We also see picking in berries. That's more controlled environment. Again, it doesn't go very fast, but again, if you got this growing in the right height, at the right setup, you could have a robot go and pick these very delicately every time so you don't damage it, and you can make sure that it's ripe when you harvest it. Then we have for pharmacies for production of different medicine, handing that out. Sorry, you have pick and place robots, so you don't have operators going around finding the right shelf, finding the right product. You basically just push a button, scan something, and it gets out to the operator there. We have picking for shelves as well. This is more research and development for now, but if a robot could walk around and pick products from shelves, that would be a lot easier than other picking operations because it's more inexpensive to have shelves than an intricate system for storing in different levels. This one is a bit more complex. So grocery order fulfillment. So if you buy groceries online, this could be one of the examples of how it's used. So mobile robots would bring different products to a robot, and that robot would pick that product, place it into a shopping bag, and get a full order fulfilled, basically. Other places, automatic storage and retrieval systems, where you get boxes in and out of racks, has been combined with picking. So you could actually get 2 bins out, pick an item from that bin, and then put it back instead of having that bin move all the way to an operator that would pick it manually. We see a lot of fast pick and place in production of electronic equipment. This example is to build an LED panel. So you place a lot of LEDs very precisely in arrays to get the right amount of light, basically, from the full panel when it's done. The other end, SMD, so components for electrical circuits, quick picking from huge rolls. Camera is checking if each piece is actually picked up by the small gripper or suction cup and is placed on the board afterwards. Need a bit of water for this speak talk. So car body. So we have a lot of heavy pick and place in the automotive industry. Some of it is done by moving around by mobile robot, but other pieces, they actually lift up the entire car and move it around, or to add pieces such as the windscreen and the doors and so on. Some places we see that the robot can both pick and place and actually handle tools. So the first there was a tool it used to cut off the wires, just put down the tool and then picked up the part and moved it along the process. So this is one of the more intricate ones where you can have multiple capabilities of a robot, basically. Sometimes you need to combine different robots for pick and place. So you can see here the first Delta robot is picking very fast from an output line and stacking. The second robot has 60 degrees of freedom and is more flexible and can actually pick up the stack and place it and align it one at a time in the tray. This is a very normal one where you get a random flow of objects out of a production, and you place it in predefined slots for a flow wrapper to get it packaged, basically, and coming out as a finished packaged product that can go directly to the customer. It has to be sealed for quality purposes or for contamination. This is an example of a automation of a direct manual process. So this was beforehand a manual process, and instead of redoing the entire process, you basically just replace the human hands with robot hands, and then they do the pick and place and holding while the whole thing is operating. Sometimes the pick and place includes value adding as well. So this example is where unfolded box is picked, and because of the way it is moved along a path as it's placed over at a taping machine afterwards, it's actually raised and ready for use. We see a rise in AI being taught, as I said, on how to pick and place objects. That's very interesting because normally that kind of dexterity is something only a human would have. This is still a very early stage, I think, but it can definitely be a nice element to align in the industry. In food production, we do see in a lot of areas, for example, for cooking here, for deep frying, that robots would handle this as it is. Sometimes repetitive tasks. It involves hot liquids and can be harmful to the operators. And the last one here is a hot dog picking and placing robot that is serving hot dogs. And just an example of it doesn't go right every time. So in this case, there was a misalignment and an unintended change in the environment, so it missed it. And this poor person who wanted a hot dog basically just gets the sausage instead of the whole thing. All right, then that's all for me. Thank you very much for listening in. By all means, reach out if you have any questions. This is my email, connect on LinkedIn. But other than that, back to you, Tim, and thank you for the opportunity to talk here.
No, thank you so much, Mikkel. Did not expect to see a robot attempting and failing to pick up a hot dog as part of today's presentations, but I do think it's an important thing to see sometimes when everything isn't aligned properly. But thank you so much for outlining so many of those things with these pick and place solutions. And I had a couple questions for you, and I guess the first one that I wanted to throw at you, Mikkel, was you just went through so many different pick and place technologies with arms and cobots and vision and AI. And, I guess if you could boil it down from a potential customer perspective, when you're looking at these solutions out there, how do you determine which ones are mature enough and ready to deploy in your environment? What are you looking for? I guess, what do you need to look for to determine that maturity level?
Yeah, that's a very good question, and somewhat of the holy grail, I think, on this one. How do you actually do that? So when we advise our customers, we always advise them to find a company, as I said, with a proven track record as an integrator, basically. But some of the underlying technologies are often difficult on your own to really assess. So the best recommendation would be to find equals or find peers that maybe have some insight, have done it before, find somebody who trust, find somebody independent, or maybe go on a trade fair and see what's out there and if they all use that technology. Because if it's a one-off, if it's cutting edge, if it hadn't been seen before, that's an indication it may not be that mature, but it's really difficult to really get aligned. So, I mean, I take if you get a scope, if you get a quote, take it to somebody you trust, somebody who might have tried a similar technology, take it to somebody who is unbiased, ask them, what do you think of this? Do you think this will hold up? Have you seen examples out there? See if you can find something that's working similarly.
On the KPI or the metric front, for example, again, from the customer point of view here, what are a couple KPIs and metrics that they should focus on when they're looking for a pick and place solution? Obviously, everybody's probably going to think throughput first and foremost, but would you prioritize that one as the most important? And then what other ones would you want to include in there?
Oh, that's a very good question, Tim. I think some of the key ones that we look into is, let's see, a few benefits. So first of all, if you look at the staffing, that's normally the issue that we see out there, that it's not that people want to get rid of their workers by all means. It's more that it's a matter of retasking that amount of workforce you have to the processes where they provide the most value and where it's less repetitive, basically, that way around. So that whole setting that up, that means that it's a matter of looking at productivity increase. So we see sometimes that you could get from one operator doing 100% of work, where if you get two robot assistants for that operator, maybe he can do twice the work that way around. So KPI is definitely how is your productivity increase, either for the production or before you scale up and build in a much more bigger setup and automate there. Another one would be safety is normally top of list. So any places that you have a near accident or an accident or have somebody that's exposed to that, we see that tremendously as a KPI that you wanna keep up. How many accidents can we potentially improve by doing this? Another KPI would be robustness requirement. I mean, what would be the uptime requirement? What would be the accepted failure rate of this? What is the impact if it fails to pick up something? Will you have a customer complaint or will you have a plane crash? I mean, there's different levels of difficulty and consequence of this, basically. And then mostly, finally and foremost, if you look at the financials of this, you want to know exactly when the return on investment is really reached, basically. So what is the payback period? And you want to make sure, as I said earlier, to calculate that based on the total cost of ownership. So it's not enough to see operators cost this per hour, solution cost this, payback time 1.5 years. It's a matter of understanding the whole process, the entire change process, and getting that in. Then you have a good picture of some of the key KPIs that we normally see.
So I know you just rattled off a bunch of KPIs and metrics, but my follow-up to that would be, when in the process do organizations need to start thinking about these? Is it after they've identified the process that's ripe for automation? Is it after they've had some of their proposals submitted to them? When in this process do customers need to really boil down to, these are the three most important things that I need to follow and make sure I will get the proper return on for a pick and place solution?
That's a key question, and that's actually spot on also on our way to move and work. So I think you need to do that upfront always. So the first thing we do whenever we come on site is not looking at the production, because then we would just get fascinated and see where can we put in robots. That's not how it should be. The first thing we should do is to sit down with the people there, the ones that want to introduce automation, and not talk about automation, but talk about what do you want to achieve, basically. That could be throughput increase, that could be labor shortage mitigation, that could be quality improvement, that could be preparing for a future site, it could be reducing overhead. I mean, anything in there, but that's the first thing we do. We sit down, we don't spend much time on it, but we sit down, ask the key stakeholders, what is it you're looking to get out of this? Because if we can achieve that without needing to do automation, that's the first choice. I mean, if we can do some of that by just optimizing or changing a flow or changing a procedure, that's the first way to do it. If not, then with that mindset of what they're looking to achieve, which KPIs are you aiming to fulfill, then we go out and we spend a lot of time in production knowing exactly what optimization options we're looking for and which KPIs to fulfill. That makes it much easier to find the places in the production where you can add tangible value with automation, because we're looking at the KPIs. I'd always say KPIs first and last, because once it's implemented, we want to test that it actually lived up to those KPIs. And sometimes you could do some changes afterwards that will make you get a lot more benefit from the work you already did and the investment you already made. So definitely first, but also last.
A couple more for you here, Mikkel. Now, say an organization is at the point in the process where they've identified some possible solutions they want to implement into their organization. They've got some proposals. Maybe they've run some tests. They've seen these robots and cobots at some trade shows, but you have all the information and now it's getting to the decision-making time. What would you say is like the first thing an organization should do after they have everything gathered and they're ready to make that decision for what they want to implement?
That's a good question, because half of the work we do is leading up to that decision, because once you got that whole foundation, you can make the decision, then it's a choice you made with open eyes. But after that, the first thing you do once you have all of that, you need to make sure that you get the right people involved, because it's a recipe for failure if you down the line get input or involvement from somebody who may disagree or want to take the project in another direction while it's running. So I'd say once you have that full package of information, make sure you get aligned with all the key stakeholders in your organization. Make sure you get aligned with potential suppliers so you know that what they're offering is actually what you need. Because if you come back later and say, well, I know I proposed this and I thought this was the solution I needed, but now it turns out it's not, it becomes twice as expensive, something like that. That's difficult to change later. It will not have the same kind of level of trust. So get everybody aligned, get the information in the organization to those that need to see it, and get a real thumbs up, a real go, and then go start investing in this, because that will mean that you have inside knowledge, you have inside backup, you have inside okay basically to go ahead, and you can go full on the project afterwards. And maybe last thing for that would be a tip: find somebody in-house that can be the key person for this. I mean, who can be the key, the flag holder, the guy who will run and lead this project and really wants to own it and wants to do it, because there will be plenty of resistance for many automation projects. But if you got that one champion that will kind of help push this through, it'll make it a lot easier to achieve.
And the last question I had for you, Mikkel, before we wrap up, you showed it at the end of the video, and I know I made a joke about it, but what are some of the pitfalls that organizations need to be mindful of and obviously have to avoid with these pick and place options outside of, again, the robot not misaligning and not picking up the hot dog in the proper manner?
Yeah, that's a good question. Maybe a few points to that. I think that's a whole session in its own. A few points could be um, a key pitfall is that you overdo it basically. So you think of, I want this pick and place operation done. It's doable. You get into the project, and down the line, it say, well, it'd be nice if it could also take this part and this part and this part and this variant, and the whole project becomes so complex because it has to do everything that it will do basically nothing. So it will become so advanced that it cannot robustly do the thing you needed it to because you wanted to add on additional nice to haves, basically. So I think the key point and the key pitfall is stay true to your scope, stay true to your level of automation, what you're aiming for, instead of necessarily navigating and changing that too much down the line, basically. Another one might be diving into something that you're not prepared for. So again, making sure that the requirement for automation stems from a production and operational need rather than a technology fascination and a need to just go and buy something and put it in. We see so many robots standing out there gathering dust just because they thought it was nice to get in, but they didn't understand what they were getting themselves into. So if you just buy a piece of equipment and expect it to be running all by itself, that will not happen. So you have to do it really realistic. You have to set aside the resources also internally and invest that man-hour time in getting it up and running and getting it maintained and keeping it running. It's just not something that comes in. So key pitfall would be to just buy a piece of equipment and think it is that, because automation piece is an automation project and you need somebody there to help you along the way. So find a good integrator, make sure you have good chemistry, make sure that you actually are able to communicate, so you will really be able to lean on that integrator for support, or like we do, jump in and be that unbiased advisor, so you have somebody to advise you along the way.
Well, we're going to wrap things up here. Mikkel, I just want to say thank you again for the presentation and outlining so many of the important things that organizations need to be aware of when it comes to these pick and place solutions across industries. So I want to say thank you again for joining us today. And I've got some housekeeping stuff here, but it was a pleasure chatting with you as part of this presentation. So thank you so much.
Thank you for getting me here.
So for our audience, as a reminder, again, a PDF copy of today's session along with other related content can be found in the resources box on your console, along with the RAC session pick and place page. Now, at this time, before you leave, if you could please fill out your feedback survey that's open on your browser window. We greatly appreciate it. It will help us develop better conferences and virtual webinars on Robotics 24/7 moving forward. And this is it. This was the final presentation of RAC 24. So thank you for attending our pick and place session, and entitled again, Pick and Place Automation, So Many Options, How to Choose. And our thank you again to our today's speaker, and that's Mikkel Vieir of How to Robot, and also our presiding sponsor of RAC 2024, and that's Corber. Now, the other sessions that were released on today's RAC 24 will be available on demand now. Everything is done with our presentation. So we thank you so much for joining us for all of our 2024 Robotics Application Conference. You'll receive more about how to view the videos on demand from an email from Robotics 24/7. So once again, on behalf of our guests, Mikkel Vieir of How to Robot, Tim Culverhouse, Editorial Director of Robotics 24/7, thank you for joining us in this session in all of our 2024 Robotics Application Conference presented by Corber. Enjoy the rest of your day, everybody. Thank you so much.